RamBOTs is a 4-year robotics project with collaborators across many disciplines of engineering, with 3 electrical engineers, 4 computer engineers, 3 mechanical engineers, and 4 vertically integrated project or VIP members. The RamBOTs team is ready to advance the design and functionality of a quadrupedal robot, affectionately named Sparky. To be able to walk, dance, and more, Sparky incorporates technologies like inverse kinematics, sensor fusion, embedded programming, safety-focused power distribution, and machine learning. Our team aims to enrich our own education and hands-on experience while collaborating with the EC Outreach Department to inspire future engineers through an exciting and engaging project.
Going into this semester, while this is an ongoing project and Sparky was a relatively complete design, we still had our work cut out for us. Sparky was far from operable. Old PCBs, wiring, part designs, and structural 3D prints that had begun to degrade and warp left us with some substantial repair work, and with the addition of some new members and an entirely new mechanically dedicated section of the team, we had a lot of extra brain power at our disposal as well.
The RamBOT draws a wide range of tools which pertains the mechanical side, electrical side, and computer engineering side. On the electrical side, we use Easy EDA and Autodesk Eagle for the PCB design and schematic captures. For the mechanical side, we use SolidWorks and Onshape, which serves as our primary platform for 3D modeling and component design. On the software development side, it's centered around VS Code, which is our primary IDE, with Platform I/O with our state low-level microcontroller interaction, and C++ and Python as the backbone for our code base.
Skills we're using have been developed beyond more than just the technical skills required to operate and work on the RamBOT. It's gone beyond just the technical engineering interdisciplinary skills like soldering, coding, and robotics component manufacturing. We've had to move more importantly into communication and presentation skills. We developed that over the year because the ECE department requires the RamBOT to be such a large part of our outreach program. So each member of our team has to communicate on a large team, but also be able to present to a wide range of people of all ages and backgrounds.
We've learned a lot while working on this project. From the technical standpoint, there's a lot of electrical design, power distribution, custom cabling, PCB design, large-scale documentation, UI framework, which we've all learned. But additionally, from project management side of things, Gantt project management, so Gantt timelining, team management, so like a large scale. What does it mean to properly plan a team, critical path, A versus B tasks, things like that as well.
The RamBOT team's main goal was to focus on making Sparky reliable and fully functional, as it has been an obstacle to get Sparky at its full potential. Throughout the project, the team strived to work on getting Sparky new upgrades in the hardware and software sides to ensure he can be easily transported and deployed for department outreach events. The team put much effort into improving the hardware infrastructure and incorporating custom PCBs, cable management design, and shifting into a new power system. For software, the team saw the purpose of creating more test cases to pinpoint where problems are occurring in order to fix them more efficiently.
The ARM is a new addition to RamBOTs this year. We wanted to give Sparky a way to interact with his environment, so we built an ARM that essentially gives Sparky the ability to play fetch. We began with a general idea and made a simple CAD model of what we wanted the ARM to look like. After that, we estimated the torques on each joint, and finally, we printed it and are using EDA to create a custom PCB for the final iteration of the ARM.
We've started developing a RamBOT Mark II from scratch, hoping to improve on a lot of the design flaws of the previous version and create something our team can really call our own. So far, our work includes researching motors and figuring out the right leg configurations to use, and we've chosen a design and are getting on to modeling.
So what the RamBOTs team considers success is having an operational RamBOT. This means being able to walk, do push-ups, and dance. This team has been heavily focused on maintenance and improving the current infrastructure. This includes a new power revamp, cabling management, and PCB boards, as well as having a fully operational RamBOT. The team will have a new modular arm that will be attached onto the RamBOT to be able to operate and grab certain objects with the control of an app.